Question number 36. Which of the following equilibrium shifts in forward direction on increasing temperature as well as increasing pressure? So the equilibrium has to be shifted in the forward direction on increasing temperature. So this means that the reaction must be endothermic. If we talk about the second factor which is given to us, that the reaction should move in the forward direction on increasing pressure as well. It must mean that the change in the gaseous moles, which is represented by delta Ng, it should be less than 0. So students, if we look at the options which are given to us, we can directly eliminate option 4. And if we talk about the reaction in which delta Ng is less than 0, so we can clearly see that that is given to us in the third option. So students, the first option, the second option, both of them have delta Ng as positive. So students, for this question, we have to select the third option as the correct answer. Let us look at the next question. Question number 37. The solubility product of calcium hydroxide is 1.08 into 10 to the power minus 4. Find the pH of aqueous calcium hydroxide which has 2 mole of calcium hydroxide added to 2 liters of water at 25 degrees C. So students, if we try and figure out the concentration of calcium hydroxide which is soluble in water, we have to solve for the Ksp value. So we have calcium hydroxide dissociating into calcium 2 plus ions and 2 OH minus ions. So if the solubility is assumed to be S mole per liter, we're going to have S and 2S. Now we can solve for the Ksp value. We have S into 2S whole square, it is equal to 1.08 into 10 to the power minus 4. So we have 4s cube equal to 108 into 10 to the power minus 6, and s cube is equal to 27 into 10 to the power minus 6. So in solving for the value of s, we have s is equal to 3 into 10 to the power minus 2. Now students, we have to talk about the hydroxide ion concentration which is given by 2s value. So the OH minus ion concentration shall be equal to 2 into 3 into 10 to the power minus 2, which is equal to 6 into 10 to the power minus 2. So if we talk about the pOH value, we're going to have it equal to 2 minus log 6. And if we talk about the pH, it is going to be equal to 14 minus 2 plus log 6. So which is 12 plus log 6, which on simplification gives us a value of 12.78. So students, for this question, we have to select the correct option as option 2. Let us look at the next question. Question number 38. An alkaline earth metals dissolves in liquid ammonia forming a deep blue solution. So deep blue solution is formed when the solution is diluted. Okay. The reaction involved may be represented as. So we know that the alkaline earth metal is going to get ionized into W2 plus 2 electrons, and both of these species which are generated will be solvated by ammonia. So we can have W2 plus ammoniated, plus we can have the electrons ammoniated as well. So if we talk about the balancing of this reaction, we're going to have W plus ammonia. So the amount of ammonia used up is equal to X plus 2Y. So if you look at the balanced reaction which are given to us, we can clearly see that we have to select the fourth option as the correct answer. Let us look at the next question now. Question number 39. The reaction of an acid chloride with an aromatic compound in the presence of a Lewis acid to give an acylated aromatic compound is called as the Friedel-Crafts acylation reaction. Consider the reaction. So we have been given a reaction and the major product formed is M. So we have to comment on the structure of M. So we know that AlCl3 is a Lewis acid. It is going to extract this Cl. So after the extraction of Cl, we're going to have this acyl carbocation. Now we know that if this CO leaves, the carbocation left shall be the tertiary butyl carbocation, which is very stable. So in this case, it is observed that the CO group leaves, leaving this carbocation, and this carbocation now attacks the benzene ring and shows the Friedel-Crafts alkylation reaction, leading to the formation of this structure. Okay. So if you look at these structures which are given to us, we can clearly see that we have to select the first option as the correct answer to this question. Let us look at the next question. Question number 40. Consider the two first order reaction with rate constant K1 and K2. So we have been given two reactions in which M converts into N with a K value of 2 into 10 to the power 3 second inverse, and also N is converting back into M with a K value of 6 into 10 to the power 3 second inverse. So the examiner seems to be interested in if 1 mole of M and 3 mole of N are allowed to mix in a 1 liter vessel to attain equilibrium. Select the incorrect statement. So if we try and figure out this reaction which is given to us, we have M converting into N and we also have N converting back into M. So we can have an equilibrium reaction in which M is converting into N and N is converting into M as well. So if we talk about the rate constants now, the M converting into N has a K value of 2 into 10 to the power 3 and the N converting back into M has a K value of 6 into 10 to the power 3. Okay, so we can have the K equilibrium value which is given by Kf by Kb, which gives us a value of 1 by 3. So we have M converting into N and N converting into M with a K value of 1 by 3. Now the start of the reaction, it is given to us that the concentration of M was 1 molar whereas the concentration of N was 3 molar. Now we can clearly see that the Q value is greater than K. So the reaction will move in the backward direction. So we can consume some N and we can form some M. Okay. So 3 minus x upon 1 plus x shall be equal to 1 by 3, which on solving will give us a value of x is equal to 2. So at equilibrium, the concentration of M is equal to 3 molar. And at equilibrium, the concentration of N is equal to 1 molar. Okay. Let us look at the options given to us now. The first option, it says that the concentration of N decreases from time of starting to equilibrium. This is correct, students. The Q value was greater than K, so the reaction will move in the backward direction, which will lead to a decrease in the concentration of N and an increase in the concentration of M. So if you look at the second statement, that is also correctly given, which says that the concentration of M increases. If you look at the third option now, equilibrium concentration of M and N are 3 molar and 1 molar. This is also correct, students. And if you look at the fourth option now, which says that the correct graph between concentration and time is this. This is incorrect, students, as the equilibrium concentration of M is equal to 3 molar. But in the graph, it is given to us that the equilibrium concentration is greater than 3 molar. So this has to be incorrect. So same is with the N. Equilibrium concentration of N comes out to be 1 molar. So the graph should be approaching 1 and not greater than 1 as given to us in this option. So students, for this question, we have to select the incorrect statement and we have to mark the fourth option as the correct answer to this question.